The numbers are not pretty in this problem. I could have regenerated it, but I think this is just a fact of life that sometimes numbers are not that pleasant and we need to deal with them. We're going to solve this problem with fairly unpleasant numbers. It's not that it's unpleasant, but the picture is not going to be very pretty. This is a very stubby, short, and thick symmetric trapezoid because the height is very short compared to the parallel sides. But if it's written into a circle, then it's a good trick to actually start with the circle. So what we have is that one side is 14, and other side is 16, and the height is 5. So that means that it's not as bad. This is 14, this is 16, and then this is 5 right there. And the question is, what is the radius of this circle? This would be a diameter, and this doesn't split the height in half, right? If you imagine that we go from the diameter away, you have to go a little bit farther so that this line segment is shorter. So this is not a symmetry. This is not halfway between those. What did I mention? This is another application of the Pythagorean theorem and nonlinear systems. Of course it is. But this here is a symmetry line. So if this was 14, really we're dealing with 7. And if this was 16, here we're dealing with 8. And then I think we need to introduce another variable. So if we call this x, this is going to be 5 minus x. This is how we express that two unknowns add up to 5. And then we have two unknowns, two right triangles, so we should be okay by stating the Pythagorean theorem on these two triangles. So first equation, x squared plus 7 squared equals to r squared. Looks nice enough. Second equation, a little bit more complex, 5 minus x squared plus 8 squared equals to r squared. It's kind of annoying, but it looks like we should first find the one that we are not interested. What I see is that if we subtract the two equations, then both x squared and r squared will cancel out, and the equation will be linear in x. And then once we have x, we're going to solve for r, which is what we're interested in. I just think algebraically that's the easy way out. So let me be a little bit careful. Subtraction is dangerous. So let me expand the second line. X squared minus 10x plus 25 is 5 minus x squared plus 64 equals to r squared. And under it, I'm going to write the opposite of this. So we have negative r squared on the right-hand side, and then 49 and minus x squared. So when we subtract, we get negative 10x plus 25 plus 64 minus 49. 25 plus 64 minus 49. Oh, that's nice. Plus 40 equals to 0. That's encouraging, right? X is 4. That looks reasonable on this picture. Then 5 minus x is 1, right? This is 4, this is 1. So r squared is, looks like it's 65, right? It's 1 squared plus 8 squared from the bottom triangle. And 4 squared plus 7 squared, just for kicks and giggles. 4 squared is 16, 7 squared is 49. That too adds up to 65. So interesting, 65 is a number that you can write as a sum of two squares in two different ways. Either way, what we're asked about is the radius of the circle, which I think is square root of 65. Thank you for watching.